Ever pondered if our universe is the only one out there, or if there are doorways leading to other universes? Welcome to the fascinating inquiry of the multiverse, the concept that our universe could be one among an infinite multitude, each with its unique laws of physics. Picture this, somewhere out there could be a universe where gravity pulls sideways or another where time runs backward. Intriguing, isn't it? This notion isn't a flight of fancy but is rooted in theoretical physics and cosmology. From quantum mechanics to string theory, cutting-edge scientific paradigms suggest the existence of multiple universes. It's like a cosmic Russian nesting doll, with universes tucked within universes, each distinct yet interconnected. But here's the real conundrum. Even if these universes exist, can we ever hope to reach them? Are there cosmic doorways or wormholes that allow passage from one universe to another? So the question isn't whether there are other universes, but rather can we ever reach them? To understand the concept of the multiverse, we need to dig a bit into cosmology and quantum physics. Let's start by simplifying these complex concepts. Cosmology is the scientific study of the universe's origin, evolution, and eventual fate. Quantum physics, on the other hand, deals with phenomena on a very small scale, like atoms and subatomic particles. Now let's imagine the universe we live in as a soap bubble. It's vast, beautiful, and filled with galaxies, stars, and planets. But here's the kicker. Our soap bubble might just be one among an infinite number of other soap bubbles, each existing parallel to ours. This mind-bending concept is what we refer to as the multiverse. But how did we arrive at such an outlandish notion? Well, it's an offshoot of the inflationary model of the universe. According to this model, the universe underwent a rapid expansion right after the Big Bang, creating a vast expanse of space filled with energy. This energy can spontaneously give birth to other bubbles of space-time, each with its own laws of physics. There's another route to the multiverse through the strange world of quantum mechanics. Quantum physics suggests that all possible outcomes of a situation do occur in their own separate universes. For instance, in another universe you might be an astronaut, a rock star, or even the president. However, it's crucial to note that the multiverse is not a theory in the strict scientific sense. It's not something we've observed or tested experimentally. It's a prediction, an implication of certain physical theories like inflation or quantum mechanics. In essence, the multiverse is not a theory, but a prediction of certain physical theories. So, while we can't pack our bags and plan a trip to these parallel universes just yet, the multiverse gives us a fascinating new way to understand our cosmos. It suggests that our universe might just be a tiny bubble in an infinite cosmic foam, and who knows what wonders lie in the bubbles next door. Now let's dive into the heart of the matter. Can we enter another universe? Ponder on that for a moment. The idea of stepping through a door and finding yourself in an entirely different universe, it's the stuff of science fiction, isn't it? But could it be more than that? Could it be possible even in theory? Let's start with wormholes, those fantastical bridges in space-time that some scientists believe could connect one universe to another. In theory, a wormhole could act as a shortcut, allowing us to bypass the vast distances of space and time that separate universes. But here's the catch. Wormholes, if they exist, are likely to be incredibly unstable. They might collapse the instant anything tries to pass through them. So even if we could find a wormhole and figure out how to keep it open, we're still a long way from being able to use it as a portal to another universe. Then there's quantum tunneling, another theoretical possibility for universe hopping. This is a quantum phenomenon where particles can tunnel through barriers that should be, in classical physics, impassable. Could we apply this on a much larger scale to cross the boundaries between universes? It's a thrilling thought, but again, we're in the realm of the purely theoretical. And of course we have to consider the energy requirements. Even if we could stabilize a wormhole or harness quantum tunneling, the energy required for such a feat would be astronomical. We're talking about energy levels that far exceed anything we can currently produce or manage. So, while the idea of entering another universe is exciting, it's important to remember that it remains purely theoretical. We're still grappling with the basics of how our own universe works, let alone figuring out how to jump to another one. The truth is, we're still in the infancy of our understanding of the cosmos. We have so much to learn, so many questions to answer, but who knows what the future holds? Science is always evolving, always pushing the boundaries of what we thought was possible. As it stands, the idea of stepping into another universe is more science fiction than science fact. So, what if we could prove the existence of other universes or even find a way to enter them? Imagine the revolution in our understanding of the cosmos this would bring. We're not just talking about a paradigm shift here, we're talking about a complete transformation of our worldview. It's like looking at the universe through a kaleidoscope. The patterns and shapes are familiar, yet they're constantly shifting, revealing new possibilities. If the multiverse theory is proven, it would mean we are part of a much larger cosmic landscape than we ever imagined. It's akin to the realization that our Earth is not the center of the universe, but just a tiny speck in the vast expanse of the cosmos. This understanding is humbling, but it also opens up a realm of fascinating questions and possibilities. What could we learn from these other universes? Could they hold the answers to some of the greatest mysteries of science, like the nature of dark matter or the origins of the Big Bang? Could they have laws of physics different from ours, providing us with a testing ground for new theories and ideas? And then, there's the question of life. If there are indeed an infinite number of universes, then it's likely that some of them harbor life. How would we communicate with these life forms, and what could we learn from them? The possibilities are as endless as the multiverse itself. But let's not get ahead of ourselves. As exciting as these prospects are, proving the multiverse theory is a monumental task. It requires us to stretch our scientific and technological capabilities to their limits. It's a journey that may well last for generations. But it's a journey worth embarking on, for it's in our nature to explore and discover. It's what drives us as a species, this insatiable curiosity to understand the world around us, the universe, and now possibly, the multiverse. Whether we ever find a door to another universe or not, the journey of discovery will continue to expand the frontiers of our knowledge.